Hello, so let's try this problem from the chapter 4. In a cathode ray tube, electrons are accelerated from rest by a constant electric force of magnitude 6.40 times 10 to the power negative 17 newtons during the first 2.50 centimeter of the tube's length. Then they move at essentially constant velocity another 45 centimeter before hitting the screen. Find the speed of the electrons when they hit the screen. So we need to find the speed of electrons when they hit the screen. So for this problem, firstly we will use the kinematic equation. We'll use our kinematic equation and Newton's second law for this problem. So the kinematic equation that we are gonna use in this is v square minus u square is equals to 2as. So this equation, it says that square of the final velocity minus square of initial velocity is equals to 2 times acceleration time the distance. Now we are gonna use this whole equation in terms of the x coordinate only. So when we are going to apply the x coordinate for this will become v of f of x square minus v of I x square is equals to 2 times acceleration along x-axis, and the distance is also only along the x-axis. So this is the equation we are going to use here, and v of f of x square, now since the initial is 0, this is equals to 2 times. Now this a of x, we are going to replace it, because since your Newton's second law is F is equals to m times a, so from here a will be F over m, and since we are taking only the x components, so we are going to take this ax will be f of x divided by m with delta x. So this is our equation for this, and from this v of fx is equals to plus minus under root of 2 f of x delta x divided by m. This is going to be our equation. We are just gonna solve this equation now. So v of f of x is equals to your plus minus under root of 2 times this f of x is given to us. This is 6.40 times 10 to the power negative 17 newtons, and the delta x is 2.50 centimeter. We are going to convert this to meters, so this will be 0.025 in meters and divide by the mass of electron. That's gonna be 9.1 10 raised to power negative 31 kilograms. So just square root of this whole thing, and since the velocity is going to be only positive, so when you will calculate this whole equation, it will come out to be positive 1.87 10 raised to the power 6 meter per second. So this is the first part of this problem. So next part is how long does it take them to travel the length of the tube. So to find the time it takes the electrons to travel the length of the tube, first we are gonna do from the x1 equals to 0 to 2 centimeter. And for this again we are going to use the kinematic equation. So we'll use this kinematic equation, delta x1 equals to Vix delta t plus half of Ax delta t. We're using delta t1 here. So this is the equation. So this is basically S is equals to ut plus half at square. But since we are just taking the x coordinates in our equation, so this is going to be the equation now. And then delta x1 equals to, since Vix is 0, plus half of ax and delta t1 0. From this equation we can say that delta t1 can be equals to delta t1, we can take 2 times delta x1 divided by a of x, under root of this whole thing. And again we are going to replace ax by using the Newton's second law. 2 times delta x1 divided by ax is f over m, so f of x with m here. So this is our total delta t1 for this when the distance is from 0 to 2 centimeter. Now from the second part, when the distance is from x2 from 2 centimeter to 45 centimeter. So for this again we are going to use the kinematic equation, and our delta x2 will be equals to v of fx delta t2. So from this we can say that delta of t2 can be written as delta x2 over v of f of x. Now since we have delta t1, we have delta t2, we can find the total time in this. So the total time will be delta t, which will be sum of delta t1 plus delta t2. So we are just going to add these equations. Delta t1 is our under root of 2m delta x1 divided by f of x, plus delta t2 is this delta x2 over v of f of x. So now just plug in the values in this equation. This is gonna be delta t equals to under root of 2 times 9.1 10 raised to power minus 31 into x1 is again 0. It's gonna be I need some space. So 10 raised to power negative 31 and 0.025 meters divided by f of x is going to be this 6.40 10 raised to power negative 17. So this is the delta t1, and plus 0.450, this is the delta x2 divided by the velocity, which is 1.87 10 raised to power 6. So we just need to calculate this whole equation, and for these values I have delta t equals to 267 nanoseconds. Thank you.